This week, our problems that we're going to look at are going to be particle motion problems like 1975 AB2. And in a particle motion problem, you're going to be given an equation either for the position, velocity, or acceleration of a particle. Typically, that particle is moving along the x-axis, although sometimes it may be moving along the y-axis. So what we see here is that we're given a position function for this particle, and the position function is x equals 1/3 t to the third minus 3t squared plus 8t. And the first part of the problem asks us to show that at time t equals 0, the particle is moving to the right. So in a particle motion problem, if velocity is positive, then the particle is moving to the right in the positive direction. If the velocity is negative, then the particle is moving to the left or the negative direction. So for part A, we need to look at the velocity function, which is going to be the derivative of this function that we're given here. So what we're going to do is we're going to take the function that we're given, which is x equals 1/3 t to the third, let's see, minus 3t squared plus 8t. And we're going to take the derivative of that, and I'm going to write x prime, but I'm also going to call this v of t because that's the velocity function. That just reminds me what that stands for. So the derivative here is going to be t squared minus 6t plus 8. So here we have our velocity function, and this question only asked about whether or not it's moving to the right or left at the time t equals 0. So all we have to do for this is plug in 0 for our t into our velocity function. So v of 0 is going to be 0 squared minus 6 times 0 plus 8, which is just going to give us 8 here. And of course, 8 is greater than 0. So since we have a positive velocity, we know that this particle is moving to the right at this point. So at t equals 0, the particle is moving to the right. Particle is moving to the right, and this is an important part coming up here because v of 0 is greater than 0. The velocity at 0 is positive. You must include this explanation here. So that is everything that we need for part A. If we look at part B, it says to find all values of t for which the particle is moving to the left. So if the particle is moving to the left, the velocity is negative. The best thing to do here is to look at a sign line of the velocity. So if we take the velocity, which our velocity function v of t was t squared minus 6t plus 8, we're going to set that equal to 0 to find our critical points. So if we set that equal to 0, we're going to factor. This will factor into t minus 4 times t minus 2, which means our critical values are going to be at t equals 4 and t equals 2. So then we can take those critical values and put them on our sign line. The sign line can begin at 0 because the problem tells us that t is always greater than or equal to 0 for this problem. And then we're going to include 2 and 4 on our sign line. I'm going to have t minus 4, t minus 2, and then, of course, my velocity function, which is what I'm really concerned with here. So if we make our sign line, if we were to choose a number between 0 and 2, like 1, that would make t minus 4 negative. This would be negative, positive. Here for t minus 2, we'd have negative, positive, positive. And then, so that means that our velocity function is positive between 0 and 2, negative between 2 and 4, and then positive again whenever t is greater than 4. So we're looking for where the velocity is negative. Velocity is negative right here between 2 and 4. So I would say the particle moves to the left when 2 is less than t less than 4, because v of t is less than 0 on this interval. So that velocity is negative on this interval. That's all you need for part B. Let's move on to part C. Part C says, what is the position of the particle at time t equals 3? Now, this is a very simple portion of the problem. All we need here is position. This doesn't involve any calculus. We just need to plug a 3 into our position formula. So if we take our equation, and I'm going to call this x of 3. X of 3 is going to be 1/3 3 to the third minus 3 times 3 squared plus 8 times 3. Here, 3 to the third is 27. A third of that would be 9. 3 squared is 9. 9 times 3 is 27. And 8 times 3 is 24. We've got 9 minus 27 plus 24. If we did this part first, 9 minus 3 and 9 minus 3 equals 6. So x of 3 equals 6. The position of the particle at at t equals 3 is x equals 6. So there we have found the position at t equals 3. The last part here asks us to find the total distance that the particle has traveled whenever t equals 3. Now, if we look at our sign line, from 0 to 2, the particle was traveling to the right. Then at 2, it turned around and it traveled to the left all the way up to 3. So to consider the total distance, we have to look at the distance traveled in this section and the distance traveled in this section. We can't simply give the answer for part C, where it went back to, because we want to know how far it traveled, not where it ended up. So what we need to know for part D is we need to know the position that it started off at. So if we find x of 0, if we plug 0 in to our original function, 1/3 times 0 to the third minus 3 times 0 squared plus 8 times 0, that's just going to give us a 0 there because we have a 0 with all of those terms. So the starting position is at 0. We also need to find the position at 2 because that's the point where the particle turned around. So 1/3 times 2 to the third minus 3 times 2 squared plus 8 times 2. This is going to be 2 to the third is 8, so that will be 8/3 minus 12 plus 16, which is going to be 8/3 plus 4, which is 8/3 plus 12/3. So we get 20/3. The position at whenever the time is 2 is 20/3. And then we have already found that x of 3 is 6. We found that in part C. So the distance traveled here from 0 to 20/3 is going to be 20/3. And then to go from 20/3 to 6, our distance is going to be 20/3 minus 6. And that would be 20/3 minus 18/3, which is going to give us 2/3. So we've got a distance of 2/3. Therefore, our total distance traveled by the particle here is 20/3 plus 2/3, and that is going to give us 22/3 for our total distance. The particle traveled 20/3 units to the right, and then at time equals 2, it turned around and it traveled 2/3 units to the left. So if we add both of those together, we get the total distance that it traveled. Both of these should be positive in this case. And that is all that we have for 1975 AB2.